the different ETL tools. So let's start with to understand what is ETL. Consider a workstation. What are the objects you find? Employee, computer, chair, books, and so on. Every object has a set of characteristics like name, ID, role, company ID, company model, name, category, and so on. Now, suppose an organization or a business wants to view or analyze the data across the organization. So you can see it's a huge data. Merging the data or managing the data with low coding or high performance can be done with using a ETL. Now let's see. Before that, let's take an example here. Suppose a company wants to know the infrastructure cost or maintain the infrastructure details like employee workstation, employee system details, employee records, or employee library records. With ETL, data can be combined or merged from different sources. For example, employee records may come from Oracle database, system records from some applications, and library records from some flat file. So all of these sources can be merged and the data could be analyzed for different purpose. Now let's see what does ETL stands for. ETL stands for source, extraction of source, transform the data during transit, load the data to the desired database either by job schedule or by triggering. ETL stands for extract, transform, and load. Extract from the source, transform the data during the transit, and load the data to the desired database. It's either by job schedule or by triggering an event. So further explained, extract is retrieving the data from same or heterogeneous sources. For example, RDBMS, flat file, XML, or other sources. The extract step covers the data extraction from source system and makes it accessible from further processing. The main objective of extract step is to retrieve all the required data from source system with little sources as possible. The extract should be designed in a way that it does not negatively affect the source system in terms of performance, response time, or any kind of locking. There are several ways to extract: increment extract or full extract. Let's take an example for extract. Here, I hope you can see my screen here. So we have two sources, a customer and sales. Customer table has customer ID, customer name, in type, entry date. So for full load on 22nd of March, we will read 2 records from customer and 3 records from sales and load them to the target table. On 23rd, we will read 3 records from the customer, including the earlier 2 records. So 22nd, 23rd, 23rd, full. We will read all the 3 records from the customer and 5 records from the sales, including the older one, and load them to the target. So we will read all of the 5 records and load into the target. Now, in case of incremental load, on 22nd March, we will read 2 records from the customer and 3 records from the sales. Like as the dated, we'll read only these 2 records on 22nd of March and load to the target. And from sales source, we will read only 3 records and load into the target. On 23rd, we will read 1 record from the customer and 2 records from the sales, like 1 record from the customer and 2 records from the sales. So this is a target which is an incremental load where we have no duplicates. So this is extract. Now let's come to transform. Transform implies to set of rules on source data. Converts a set of data values from data format of source system to the data format of the destination system. Data cleansing, data validation, data manipulation, filtering, tuning, consolidation, everything is done within the transformation. Let's take an example for the transformation. Consider source employee information. We have columns like employee number, name, code, number. So basically, if a business requirement, there is a business requirement like combining area code and number with a pattern including hyphen for the contact number, and if the area code is null, then send the data to the error table. So these are the basic business requirement what we have to handle. So during the transformation we do handle it, and the data for the first record, like we have the area code and it's a valid record, so we are transforming it to the desired pattern or format. Now the second record, the area code is missing, so as business rules we are sending it to the error table. So this is an example for the transformation logics or code. So within Informatica, this is how we will do it. Like we'll have a source, we'll have a expression, and we'll have a target. So basically we will handle this kind of transformation logics within this, but we will have a more detail during our further course. So transformation, basically just have a scene example. Data transformation activities should be properly implemented to produce clean and standard data. So with one example, we could see a few of the scenarios, like we handle some business requirement pattern and also handle the null value. Loading. Loading is a process is a very time consuming and needs attention. We either can full load or we can go for an incremental load. Full load is we read complete data from the source table and set or update the target table. We read only in incremental load, we read only the few records which are not read or processed before, or insert or update those records. Sorry. Loading can be done trigger based or it can be scheduled. Let's see an example. Suppose this is example is based with Informatica. Suppose we have a workflow. Workflow is basically triggering a job. Suppose we have a workflow and there are different tasks available. So session is a task where basically a table, data information is loaded to the from source to the target. So this basically a session does. So session is basically, now suppose a table A, data is loaded from table A to the table B, and this is an assignment task where we basically assign some variables, and this is a command task where we basically do some kind of commands, pass the commands, maybe back of the source file or deleting of the file. So these are the loading process. So it is like we are handling certain events or doing some tasks. There is one more example. Here we are waiting for a trigger or an event. Maybe we are waiting for a source file, or we also have a timer. So either of this kick starts first, then decision making will be done based on the decision making, whether it is success or fail. So if it is a success, we will start the session. Session is basically the loading process of data from a source to target, and then we will, if it is failure, then we will send an email to the business or the desired person. So this is a type of different types logics which could be handled during the loading. So like basically handling the business requirement by data load. These are few of the scenarios. So let's understand basics of data warehouse. Data warehouse is defined as a subject-oriented, integrated, time-variant, non-volatile collection of data in support of management's decision making. So, what's subject-oriented? Subject-oriented means data is based on a particular subject, maybe sales, accounts. Integrated, meaning the data is combined from multiple data sources, maybe RDBMS, flat file, Excel, XML, and so on. Non-volatile, data is preserved, unaltered. Time variant, one can retrieve the data from 3 months, 6 months, 12 months, or even the older data. Data warehouse is a system used for reporting and data analysis. Data is used for decision making. Let's see what is OLTP. OLTP is online transaction processing. An operational database or a transactional undergoes frequent changes on a required basis on account of transactions that takes place. Suppose a business wants to analyze history or any data such as product, supplier, or any other data, then the executive will have no data available to analyze because the previous data has been updated due to transactions. Let's see an example here. In online transaction processing, we just have a current value of the product, which is $95. In data warehouse, we will maintain the history of the product from the day the product is available or the data is available. For example, product A, the price of the product A varied from $100 to $95 from January 13 till date. So this particular data is used by managers, analysts to review or analyze the product market value to answer the basic questions like why, what happened, and when. Salesperson in OLTP system, the salesperson sells the product at this price. So he is not aware what is happening with the product. He's just selling the product. In data warehouse, we are analyzing the product. So to know the structure of data warehouse has a dimensional model with star and snowflake schema. Within this schema, there are facts and dimensions. Facts is a central data which contains quantitative data, a central table which consists of the quantitative data, and dimension is a descriptive information. So this is a model of dimensional star model. So let's just take a small example to make you understand about data warehouse. Suppose we have a data, suppose we have a company XYZ in two locations, like location A and location B. So these are the transactional details day wise, which we have order details, basically order, product number, quantity, amount, and transaction date. So this is a product sales history what has been maintained in two locations. Suppose now business comes with this, it's very difficult to analyze what exactly is going on, whether the product has been sold, which month this is sold, or what exactly is happening with the product. So suppose the business comes up and wants to know few of these requirements, like product sales per month, sales per product, sales per locations per product. So these are the few scenarios what business wants to know. So for this, we can come up with a model, a dimensional model, where this is a fact table, which is a central table, which is a quantitative data, and these are the location, date, and product are the dimensions table, which are surrounding the fact table. Basically, these are descriptive data where you can see location, we have the name and ID, product name and ID, and data. and this is a sales where we are giving the information. We are linking the tables. So with this format, with this structure, we can get basics of these understanding, or these order sales per month. This is a reporting where we can understand say order sales per month. So in January there were so many orders. In March we had 2000. So this is a sales per month. Now sales per product is product A is 8 is sold, product B 2 is sold. This is the product wise information, and sales per location per product. So this is also like sales location will come into picture. So this is basically kind of information you can get through the system. And this is a normalized structure. This is a normalized structure. So basically this is a small example. Once we during our regular classes we'll take a better or examples and try to understand more on data warehouse. So data warehouse architecture. Data warehouse is where the data from different source systems are integrated, processed and stored. Data from data warehouse is mainly used for analyzing and reporting purpose. ETL is a process which handles the data and transforms into more consistent and standard format of data. ETL is a process which handles this data. Here in this architecture, ETL is a layer between source and the target. ETL is a layer between source and the target. These are the sources and this is the target. Data from various systems or sources is brought in and transformed and loaded to the target. Various systems like operational system, ERP, flat files and so on is brought in, transformed and then loaded, which further used for reporting and analysis. ETL takes around 50% of data warehouse implementation. Sorry. This includes understanding of logical, physical data, source data, business rules, and so on. It's a crucial period during the data warehouse projects, ETL part. There are many tools available in the, there are many ETL tools available. Few of them are listed over here, like SAP, IBM's SAS, PowerCenter, Informatica, Data Integrator, SQL Server, Open Text Integrator, Oracle, Cognos, Clore, Pento, ClickView, and so on. Now, let's see what are the types of projects where actually ETL comes into picture. Rolling up of transaction data for business to work with, which is commonly called data marts or data warehouse. Basically, this is a transactional data. We just saw an example where we have day-to-day transaction data and we are rolling it up for some summary or some analysis. So these kind of projects. Migrating the data from all systems to new ones. So suppose the business already have or organizations has access database and it, now the requirement is to move to the Oracle or a for a newer implementation. So this kind of migrating database. And merges or acquisitions, like two or more companies coming together, say combining their databases, combining their values or businesses, such kind of projects. Integration of data from external suppliers, like now let's consider online shopping. It's a online shopping is a platform for various small vendors, like vendor ABC or so. They come together, sell their products. So it's like basically getting the data from various vendors. So these are the type of projects. There are many, but these are the few type of projects where ETL comes into picture. Consideration for ETL for selection of ETL tools. data connectivity, performance, transformation flexibility, data quality, flexible data acquisition, data connectivity. The ETL tool should be able to communicate to any data sources such as relational, file-based, others. Performance should be able to scale for further data growth. Transformation flexibility should always should allow various transformation for matching, modifying, merging the data with just drag and drop option. Data quality should allow good information, clean data and valid data. Flexibility of data acquisition should have flexible to load data by time interval or trigger based. Should be able to process all the data or subset of data. As we already saw, we can either all the data or subset of data could be loaded. So basically, this is the small demo for ETL tool. Now let's understand the module, what we'll be covering during our training programs, and also go through the training plan. So we'll just have a brief understanding about our modules. So during our training, we will cover various modules like module 1, 2, 3, 4, and 5, which is kind of categorized. So module 1, we will have data warehouse concepts and data warehouse architecture, dimensional modeling, understanding of OLAP. In module 2, we will have ETL and Informatica client tools, understanding of 9 architecture, structures of Informatica, folder structure, source, file, and like different structures. Module 3, we will focus on development of with transformations. Basically, we'll take most of the transformation, not all are been noted down here. So we'll have source, expression, aggregate, sorter, joiner, transaction, control, rank, normalizer, and so on. So we'll also cover the parameters and variables, mapping variables, workflow variables, debugging the mappings, and we will take more with all of the expressions. We will try to take most of the scenario based examples. We'll have a lot of examples covering up. In module 4, we will basically work on schedule and monitoring of jobs using workflow and monitor. We'll learn about different tasks such as email, assignments, timer, etc. Understand and execution of few commands like copying, saving the file, deleting the file, and so on. Understand the logs and troubleshoot. Basically, for troubleshooting, understanding the logs is more important. So we will understand those, troubleshoot for performance also. In advanced topics, we will implement the SCD types like 1, 2, 3, target load, delta load, reusable task, and so on. So fixing the bottlenecks, working with increasing performance, real-time scenarios, these are the part we will take in advanced topic. There are many more like which not all been mentioned. So increasing performance is one of the thing where everyone like to know more about it. So in module 6, we will cover up the repository manager, importing, exporting features, versioning, maplets, worklets, and we'll also have an assignment with a kind of real-time projects where we'll work on the brainstorming where how the project execution could be done. So this is a module-wise brief understanding. Let's see the day plan. This is a tentative dates what been mentioned. So it will be a day-wise plan where we'll have the which is actually segregated with the topics what is shown. So we'll have in complete introduction of data warehouse, the full session, and then we will have this architecture components and versioning on the second day, and then we will have the understanding of the tool basically for a complete and then we will start with the transformation. So like we'll have different transformation for most of the week here with all examples, most of the examples, and then we'll have a parameter file and variables, scheduling task and task worklets, standalone task, real-time examples. Then we will have SCD1, 2 types, loading types again, and then mandatory. So these are the basically we will take considering the day-wise plan, and then finally basically 2 days to understand the assignment or the project. So for day we will understand the project what is supposed to be done. Second day we'll try and execute few of the project tasks within this. So this comes to be 25 days of plan. So we can even add few of the other this one. So current this is the plan which is here. So now yeah, I think done with the most part demo here. So if you have any questions, can let us know.